In this product case study, we disassembled an office chair to analyze the manufacturing processes used to create the product. This adjustment knob was manufactured through injection molding. Injection molding would allow the manufacturer to produce many parts quickly. Indication of this manufacturing process would be this injector pin located at the top of the knob. This metal arm could be cut from a long extruded metal plate. The metal plate would be cut at certain lengths before each piece would be rolled, then end milled to make these features.
These three parts allow the height of the armrest to be adjusted. The two plastic pieces were created using injection molding. They both contain obvious ejector pin witness marks. The spring is likely made of bronze, an alloy of copper and aluminum known for its strength. It was most likely rolled into shape. This plastic backing plate was also created using injection molding. Again, ejection pin witness marks can be seen throughout. Tolerancing was important on this piece. It is critical that the outer diameter of the mounting pins is less than the inner diameter of the mounting holes. Thus, the maximum material condition was important when calling out the outer diameter of the mounting pin. Also, the relative position of the mounting pins must be kept accurate in order to ensure that the pieces can mate together.
The backrest of the office chair is assembled to a metal plate, which has a metal rod welded to the end of it. The welded components may have been joined together using shielded metal arc welding. The welded joints appears to contain weld metal, indicating a consumable electrode. The weld may have also been achieved using MIG or oxyfuel methods. The weld profile shows that there is discontinuity in the weld joint, which signals that the weld may have been done manually, and there is much overlap. The surface overlap may be for a number of reasons, such as improper amount of current, preparation or selection of material, an untrained welder, or improper welding technique, just to name a few. The metal base of the office chair shows that it was stamped and had a few operations done to achieve its structure. Firstly, a flat metal blank will undergo a number of die cutting operations, such as perforating to cut the holes you see. The holes that are cut are then threaded with thread dies. The metal will have a notch cutting line that will relieve all the compressive stresses in the corner that is being bent to a 90-degree angle. The relief cut will also help with the inherent spring back of the material from the bending operations. The wheel and wheel assembly for the office chair is made of thermoset material. This is very hard and made by injection molding. The wheel assembly's parting line, which is the line that separates the upper and lower halves of the mold used to create the part, is made by the liquid thermoset material being squeezed out between the two halves of the mold.
The pin that goes through the wheel is a single piece of metal with sections of different diameter and circular markings. These features indicate the pin was turned on a lathe and polished. In order to be cost-effective, the plastic component of the ball bearing was most likely stamped out of a sheet of plastic. The metal balls started out as a wire and were die forged into a ball shape. Additional grinding and polishing were used to remove the flash. The star-shaped base of the chair was injection molded. The small but noticeable deformations on the crossbars, along with the dials indicating the production date, are clear evidence the piece was injection molded. The spring was most likely formed by a CNC spring coiling machine, which feeds metal wire through a hole and simultaneously bends it into the desired shape.